Welcome to another information video. Today we will talk about robotics history. Before we proceed, do subscribe us and press the bell icon for daily updates. Nowadays we are surrounded by lots of mechanical devices, and humans are rapidly enhancing these devices. Yet there is a question in our minds where this all began. This all began around the 11th century. The birth of a genius boy named Badi al-Zaman Abu al-Izz Ismail ibn al-Razzaz, al-Jazari, in the house of a humble craftsman. One of the most fascinating cases is that of the 13th century inventor-artist Ismail Al Jazari, who not only laid the groundwork for modern engineering, hydraulics, and robotics, but recorded his designs in a manner that would excite any enthusiast of Leonardo da Vinci's notebooks. In fact, it is often claimed they may have inspired Leonardo himself. Badi al-Zaman Abu al-Izz Ismail ibn al-Razzaz al-Jazari was born in the area of Upper Mesopotamia in 1136. Sources state his exact location is unknown, but they speculate he could have been born in Jazirat ibn Umar, where he got the name Jazari from, or al-Jazira, which was used to denote Upper Mesopotamia. The only biographical information known about him is contained in his book of knowledge of ingenious mechanical devices. Like his father before him, he served as chief engineer at the Artuklu Palace, the residence of the Mardin branch of the Artuqids, which ruled across Upper Mesopotamia as vassals of the Zengid dynasty of Mosul, and later of Ayyubid general Saladin. Little is known about his ethnic background, so he has been variously described as Arab, Kurdish, or Persian. Al-Jazari was part of a tradition of artisans, and was thus more a practical engineer than an inventor, who appears to have been more interested in the craftsmanship necessary to construct the devices than in the technology which lay behind them, and his machines were usually assembled by trial and error rather than by theoretical calculation. His book of knowledge of ingenious mechanical devices appears to have been quite popular, as it appears in a large number of manuscript copies. And as he explains repeatedly, he only describes devices he has built himself. According to Mayer, the book's style resembles that of a modern do-it-yourself book. The Book of Knowledge of Ingenious Mechanical Devices, Al-Jazari's masterpiece, The Book of Knowledge of Ingenious Mechanical Devices, 1206, contains detailed descriptions and illustrations of 50 mechanical devices. This work would influence engineering for centuries to come. Key features include precise technical drawings, step-by-step assembly instructions, practical applications, theoretical principles, automated control systems. He created the first programmable humanoid robots, developed automated music-playing machines, designed sequential automation systems, water clocks and timekeeping, invented the elephant clock, combining Indian, Greek, Arabic, and Chinese engineering traditions, created water clocks with automated humanoid figures, developed mechanisms for precise time measurement, designed advanced water-raising machines, created automatic fountains, invented mechanisms for controlling water flow, mechanical automata, designed automated peacocks that served drinks, created automated hand-washing devices, developed musical automata. Al-Jazari introduced several fundamental mechanical concepts. 1. Al-Jazari used camshafts in his automata, water clocks, and water-raising machines. Ismail Al Jazari described the camshaft in his 1206 book of Knowledge of Ingenious Mechanical Devices. A camshaft is a shaft with cams attached to it that controls the opening and closing of valves in an engine. Camshafts are critical to the operation of an engine because they control the amount of air-fuel mixture that enters the chamber and the exhaust gases that exit the chamber. Camshafts work in conjunction with the crankshaft, which moves the pistons. The shape of the cam and the speed of rotation control the rate at which the valves open and close. This is known as variable valve timing. 2. Crankshaft. Yes, Ismail Al Jazari invented the crankshaft in 1206. A crankshaft is a rotating shaft in an engine that converts the piston's up and down motion into rotational motion. This motion is necessary to turn the wheels and make the vehicle move. Al-Jazari used the crankshaft in his water-raising machines, which incorporated a crank-connecting rod mechanism. His suction piston pump could lift 6 meters of water, which was more advanced than European suction pumps of the 15th century. 3. Segmental gear Ismail Al Jazari, 1136–1206, is credited with inventing the segmented gear, which is a key component in mechanical engineering. Al-Jazari used segmented gears in his water-raising machines. He used segmented gears to transmit motion between gears more efficiently and flexibly. This led to more complex and sophisticated mechanical designs. Automated switching systems. Ismail Al Jazari, a 12th century Muslim inventor, created a variety of automated machines that included fountains that could be programmed to turn on and off. Escapement mechanism. Ismail Al Jazari, 1136–1206, invented an escapement mechanism to control the speed of a rotating wheel. The escapement mechanism is used in a wheel-rotating machine. The mechanism controls the speed of the wheel by rapidly accelerating and decelerating the verge and crown wheel. The verge foliot and the crown wheel experience a drop and freely spin. One of his most famous inventions, the elephant clock, showcased multiple innovations: automated timekeeping, multicultural design elements, complex gear mechanisms, water-powered operation, automated figurines, musical elements. Some of his devices were inspired by earlier devices, such as one of his monumental water clocks, which was based on that of a pseudo-Archimedes. 19. He also cites the influence of the Banu Musa brothers for his fountains, al-Saghani for the design of a candle clock, and Hibatullah ibn al-Hussein, Dis 1139, for musical automata. Al-Jazari goes on to describe the improvements he made to the work of his predecessors, and describes a number of devices, techniques, and components that are original innovations which do not appear in the works by his predecessors. He invented around 100 mechanical instruments. Most of them were designed in such a way that they worked automatically, which means to run without human support.